In this video, we're going to create a DynamoDB table directly on AWS console and then connect a NestJS codebase to it. Hello everyone, this is Marco speaking. Today we're going to create the backend and database side for our nodes project. We're going to create a simple nodes project where you can create nodes like digital post-its and then save them on the cloud. Our data will be saved on DynamoDB and managed with an API made using NestJS. But before we proceed, if you like this kind of content, just give me a thumbs up, share this video with your friends, and subscribe to the channel so you can learn more about NestJS and the AWS ecosystem. And never forget that the more you learn, the better you become and more value you can provide. So let's do this. Okay, great. So this is the node object and the model representation for the object they're gonna save on DynamoDB. The first attribute that we're gonna save on the database is going to be the ID. In our case, we're gonna use UUID for generating the string for the ID. We're gonna have the title, which can be optional depending on your preference for the posted for the node. We're gonna have the actual content, the string content. You're gonna have an attribute that represents the created at date. Probably on DynamoDB, we're gonna save the date as a Unix timestamp. And we're also gonna have a last updated at, which is another numeric timestamp for the last moment that we updated this node. Okay, great. So let's keep going. So here we are on DynamoDB page. The first thing that we need to do is on the left section, we go to tables and click here. So here we can see all the tables that we have on DynamoDB. So let's click to create a new table here. And here we're going to create our nodes table that we just defined here. So I'm gonna call it just nodes. For defining the key for a table on DynamoDB, you have two options. You can have a single attribute for a key or a composite attribute for a key. In our case, we only have a single string as an ID, which is the actual ID, or we can call it node ID. It's up to you. Having a composite key is useful in some situations. So for example, let's suppose that you have a restaurant. So you have a table for food, and on this food table, you can have only a string or only one attribute to define the ID. But if you have another table, another DynamoDB table like food order, so you want to save all the orders for all the foods that you served on your restaurant. So a composite key on this situation, so for example, you can have the partition key as the food ID and the sort key as the order ID. So when you go to the DynamoDB table and then you just search for the food ID, you can see all the orders for one specific food. So having a composite key in this situation can help you to sort and organize all the orders by specific food. But in our case here, for our nodes project, it's not required. Only have one attribute as the ID is more than enough. So let's keep going. So here we can see all the settings for our table. In our case, the default settings is more than enough. So in our case, we have a provision read capacity as 5 read capacity units and 5 write capacity units. I'm gonna attach some links in the video description so you can read more about the read capacity units and the write capacity units from DynamoDB. And in our case, the auto scaling is also provisioned here, is also enabled for the table. If you prefer, you can pass individually. For example, if you want to just scale the read capacity or the write capacity individually, you can do this on DynamoDB. So if you don't want to scale, for example, the read capacity, you can turn off here and set a defined value and just enable the auto scaling for the write capacity or vice versa. And you can also define the target utilization before the DynamoDB table scales up or down your capacity. But in our case, the default settings is more than enough. You can also define here the table class. You can define some other extra attributes, secondary indexes, and so I'm gonna pass some links in the description so you can read more about these extra attributes. You can define encryption at rest for the objects and deletion protection. But in our case, the default settings is more than enough for us. Okay, great. And then here, once we just define here the node ID, we create the table. Actually, the ID is the only attribute that we need to define beforehand creating the table. The other attributes that we define, for example, the title, the content, the created at, and the last updated at, can be defined after creating the table. Because as a NoSQL table, we can add or remove new attributes on the fly. It's not like SQL tables that we need to define everything beforehand. Okay, great. So here we have our new table on DynamoDB. It's already created, so let's click here. Here you can see the main information from our table. We can see here all the metrics. So here on our database, on our table, let's click to explore items, and let's create a new item directly here on DynamoDB. So the node ID is going to be a UUID. So I found this website to generate random UUID. So I'm gonna copy it here and then paste it here. And let's create a new attribute, which is going to be the title. So I'm gonna say my first node title, and a new attribute, which is also going to be a string. And in this case, is the actual content. My first node content. Let's also define the created at attribute. So I'm gonna create here a created at, which is actually going to be a number rather than a string. So we created at. So for getting the created at value, so here on the browser, I'm gonna use the date.now library from JavaScript to extract the timestamp. So I'm gonna copy this number here and use it here as the created at value. Perfect. So I use the value from date.now and I save the generated number as a timestamp for our node. Let's create the item here. Perfect. So this is our first node for our project. So we can see here the attributes, we can see the node ID, the content, the created at value, which is the timestamp, and the title. So if you want to see this as a JSON, you can click here. If you don't want to see the attributes from DynamoDB like this S and the N, the S says that this is a string and the N says that this is a number. If you don't want to see this, if you want to see a regular JSON, just click here so we can see the actual object that we created. Perfect. So this is our first node in our DynamoDB table. Now let's go to the code side and create our NestJS API. Okay, great. So here on terminal, let's start our new NestJS project. So I'm gonna say nest new. So I'm gonna call it nodes backend project. It's up to you. I'm gonna use Yarn to manage the packages and dependencies, and the installation is in progress. Okay, so the initial setup for the project is complete. Let's get into the folder and open the project using VS Code. Yes, I trust the authors. Perfect. So this is the project created by NestJS using NestJS CLI. So the first thing that I'm going to do is to install a few packages that we're going to need. So we're going to need the first package that we need in our project is the AWS CLI slash client DynamoDB, which is the client for DynamoDB for JavaScript or TypeScript. So I'm gonna paste it here. The next package that we need is UUID for generating the IDs for our nodes. So I'm gonna pass it here. For managing DynamoDB databases on Node.js projects, there's another library called Dynamos, which is heavily inspired on Mongoose, but it's not official from AWS, so I'm gonna stick to the official library provided by the AWS team, which is the DynamoDB client. Perfect. So the next thing that I'm going to do is to create a new resource for our nodes. So I'm gonna do nestg resource for creating our resource. So I'm gonna call it nodes, and our resource is going to be a REST API. If you prefer, you can do a GraphQL or a microservice using a known HTTP code or WebSockets. These are the options provided by NestJS CLI, but in our case, it's going to be a REST API. Yes, I want the CRUD endpoints, entry points, the create, read, update, and delete. Yes. Perfect. So NestJS CLI created for us a module, a controller, and a basic service. So you can see that NestJS already created the create, find all, find one, update, and remove for us. And it also created the entity class, and some details as well. So let's proceed and create in our code base a custom repository for having access to DynamoDB. So here, what I'm going to do, I'm going to create a notes.repository.ts and export a class here, which is going to be the notes repository. This is going to be the class which holds the code for connecting to DynamoDB and injecting the operations in it. So this is going to be injectable. I'm going to use the dependency injection from NestJS to manage the instance from this class. And here, what we need to define, private read only. The first attribute is the table name. If you remember well, the table name is called notes. And the next attribute that we need is the DynamoDB client, which is a DynamoDB client. And on the constructor, we're going to define our client. So this client equals to a new DynamoDB client, and then we pass the region, which in our case is US West 2, which is the Oregon region. By the way, I'm not passing the credentials here, like the username or password for accessing the DynamoDB client. I'm using the default credentials from the machine level. So in this way, we don't need to pass like the user credentials to access the library. So let's keep going. So the first method that I'm going to implement here is the find all, which is basically a scan on the table. So we're going to implement a method to return all objects here from this table. So async find all. And the code is going to be pretty much something like this. Const result, which is a node from our entity created by NestJS. So we need to define a command. Use scan command. We only pass the table name, and then we get our response. Perfect. If the response.items was defined, so we're gonna parse the the DynamoDB object into a node object, and then we return the result list. So the next thing that I'm going to do is actually to implement a parser here and to define our attributes on the entity class as well. If you remember well, these are the attributes that we defined previously. Let me define here as well the linter for VS Code. VS Code settings JSON. Perfect. So to parse an object from DynamoDB, the code is going to be pretty much something like this. So because when we scan objects from DynamoDB, we're gonna have a structure like this. So we have the node ID, and then we have this S, which indicates a string, and we have N for numbers, and so on. So we need to parse this structure, this JSON structure, into a node object, which is going to be something like this. We have the result, which is a new node, and then the node ID is the node ID.s. The title is the title.s. We have to be careful because the title, if you remember well, is optional. So this is why I have this character here, and the content. And the created at, we have to parse this as a number because DynamoDB is saving the content as an actual string. And the same for the updated at. Perfect. So, as you can see, this is a static method which receives a data object, a JSON, and parse it into a node object and then return it. So here, what we're going to do in the repository layer, for each item in the items array, response.items for each, we're going to pretty much push into the array a node.new instance from DynamoDB object, and then we pass our item. Perfect. And then we just return the result. So what I'm going to do here on the service layer, I'm going to import this new repository, which is a nodes repository. Perfect. Actually, we need to pass private read only. Perfect. Something else that we need to do is to define here in the provider section our repository. So NestJS can inject the repository using dependency injection. Perfect. So let's go back here. So in the find all, what we're going to do is basically return that this.repository.find all. Perfect. On the controller layer, it's already defined. So let's test our find all method. Start def. Nice. Let's open up Postman and try our endpoint. So it's going to be http ://localhost on port 3000 with this route /nodes. Let's try. Perfect. In our case, we only have one object on our table, so this is why there is only one object being returned. So let's keep going. I'm gonna do something similar, but now find an object by ID. Actually, our ID is a string, so we don't parse it here. And then we convert this to a string. Perfect. Now in the repository, let's implement a find by ID. Is saying find by node ID or find by ID. It's up to you. Okay, great. So the command is going to be something like this. So we need to pass a get item command where we pass the table name, and then we also need to define the key, which is a node ID as node ID. And then we pass this command to the DynamoDB client. Const result is going to be a this.client.get send, and then we send our command. If we have the result dot item, which means that we could find the object there, we pretty much return a node dot new instance from DynamoDB object, the same method that we defined previously to parse DynamoDB JSON objects. Result dot item. Otherwise, we just return undefined. Perfect. So on the service layer, what we need to do is pretty much return this dot repository dot find node by ID, and then we pass the ID here. Great. And we already defined here on the controller layer as well. So let's try the same thing. So we pretty much need to pass this and the route. It's gonna be something similar, but in this case, if you noticed, there's no list marks here. It's just one object. Whereas if you don't pass here, it's actually returning a list of JSON objects. I'm going to define the create object now so you can see more nodes object here to see the difference better. So let's keep going. The next method that we're going to implement is the create object method. So here we pass a DTO, and for the DTO we're gonna pass two attributes. We're gonna pass the title and the content, which is going to be something like this. Actually, to pass these decorators, we also need to install two libraries, the class validator and the class transformer. Oh, sorry, I need to pass the yarn add. Perfect. Now if we try again to import this and this. Nice. Now we have our DTO with the title, which is optional, and we have the content. And here we are passing the DTO here to the create from the service, and then here we need to define the create method on the repository as well. Actually, I'm going to do something a little bit different. I'm going to create another static method, which is a new instance from DTO. So we're going to receive the data, which is a create node DTO, right? And we're going to define the code to create a new object from the DTO, which is going to be something like this. So here we need to import our UUID library, which is this one. So the result is a new node result object, is a new node object. The node ID, since it's a new object, we're going to create a new UUID. The content is the data.content. The title is the data.title, which can be optional. And the created at is a new date object. And then we just return it. Result. Perfect. So on the repository layer, what we're going to do is actually to implement a upsert method. Why is that? Because we can reuse the same method to create and update objects on DynamoDB. So upsert one, and then we receive the node object. So the item object that we're going to inject on DynamoDB, which is a record, by the way, from DynamoDB, where we pass a string and the attribute value is going to be this. So we need to pass the node ID, which is by default the only required attribute by DynamoDB, because this is the key from the object. The next attribute that we're going to pass is the content and the created at. And after this, we need to check for the optional attributes. The first optional attribute is the title. So if title was defined on the node object, we also pass in the object to be sent to DynamoDB. And we also need to check for the updated at attribute. If we also have the updated at, then we pass it into the object to be sent to DynamoDB. And as we did previously, now we need to define a command. But in this case, it's going to be a put item command, where we pass the table and then we pass this object that we just defined previously. And then we send the command to our client, to our DynamoDB client. And then in this case, I'm just going to return the input object, this one. And that's it. This is our upsert. It's actually upsert 1. So we can reuse the same method to add new objects or to update objects on DynamoDB. So here on the controller layer, we're gonna pass the DTO to the service layer here. So what we're going to do in this case is to return this.repository.upsert1, where we pass a node.new instance from DTO. So we pass the DTO here, and this method can extract the attributes from the DTO and create a new instance from the node class. And that's it. Let's start our backend again to test our method. Okay, so I'm gonna create here another endpoint, which is going to be http://localhost nodes, which is going to be a post in a raw JSON. So I'm gonna pass only the content. Let's double check the attribute. So you can see that the content is required, whereas the title is optional. So I'm only going to pass the content. This is our node's content. I'm gonna say that this is my first node from NestJS API. Perfect. Has to be a post, and then we send. It seems like it was created. Let's go back to DynamoDB. So if we refresh here, as you can see, now we have two objects. And here you can see the content that we passed from Postman, my first node from NestJS API. Let's try to return this from the get method to define all method. As you can see here, now we have two objects from DynamoDB. Perfect. The next method that we're going to implement is the delete object method. So we're going to implement this one, the delete object by ID. Let's remove this because our ID is a string, not a number. So we pass here a string. And let's go back to the repository and define the delete object method. So we're going to define a delete by ID, which is going to be something like this. So in this case, it's pretty much similar. We need to implement a command to DynamoDB, but in this case, it's going to be a delete item command, where we pass the table name and then we pass the key. And this is the key structure from the object, where we need to pass the node ID, the S, and node ID. So to return, I had to pass some extra attributes. So I had to pass this return consume capacity and return values all old. Why is that? Because when we make a call to DynamoDB to delete something, I need to know if the object was actually deleted or not. Because if you pass a key that does not exist on DynamoDB, it's not going to raise any error. So when we pass this, we can see the attributes from the object deleted by DynamoDB. So if the attributes was defined, it means that the object was actually deleted. If the attributes from the result is undefined, it means that nothing was deleted. So in this case, what I'm doing is, if the function returns true, it means that we could find the object that we wanted to delete and then we actually delete it. If we return false, it means that DynamoDB could not find the object to be deleted. And then here on the service layer, we basically need to return this dot repository, the delete by ID, and then we pass the ID, which is the node's ID. Perfect. So what I'm going to do here on the controller layer is to make a few changes here. Instead of returning this attribute directly, because if we do this, we're going to return directly true or false, but I want to wrap the result as a JSON. So I'm going to do this. So when we try, for example, to delete something by the ID, for example, my first node from NestJS API, I'm going to delete this object. So let me copy this first, change here to delete, copy the node ID, and then pass it here. And then let's make the call. As you can see, it returned true. It means that DynamoDB could find the object to be deleted and it actually deleted the object. So if we refresh here, you can see that we don't have the object anymore. And if I try to make the delete call again, let's see what happens. In this case, it returns false because the object was deleted already and so on. It doesn't exist on DynamoDB anymore. Perfect. So the last method that we need to define is the update object, which was defined as a patch call by NestJS. So let's do the same as the other ones. Let's change this to be a string rather than a number. Let's update this. And let's go back to the controller. Perfect. Now let's make some changes on the service layer. So what we need to do here, the first thing to update an object that we need to do is to find the existing object. Which is going to be, need to update this to be async. This is the repository, the find node by ID, or just find by ID if you prefer. So let's check if the content exists. If the user wanted to update the content, because this is the update node DTO, which is a partial create node DTO. This is a special library from NestJS to define every attribute here as optional, because here on the create node DTO we define the title to be optional and the content to be required. But here, using the partial from the create node DTO, every attribute can be considered optional. So we need to check if the content actually exists, and if so, we're going to make the changes. We update the existing object, the content from the existing object to be the same as the DTO, and then we do the same with the title. Perfect. And if you remember well, we also defined the updated at attribute. So in this case, we passed the updated at to be a new date, which is the UTC date from the current moment. And then what we do, we pretty much return this .repository.upsert1. So we pass the existing object with the attributes updated. So this is why we can use the same method using this upsert. And that's it. The service and the controller. Now let's make some experiments. Here, let's try to find all objects from the list. Right now, we only have this attribute. So what I'm going to do, I'm going to update this object. I'm actually going to update the content. So let's create here actually new endpoint, but it's going to be a patch. And then we need to pass the node ID as a path parameter. slash the node ID. In the body, we're going to pass the content, which is going to be, I'm gonna say that this is my first node content updated from NestJS API. Let's make the call. Perfect. So this is the object updated. If we go back here to list all objects, you can see that the title was updated. And if you go back here to DynamoDB and refresh the list, you can see here that the title, the content actually was updated as well. Perfect. And that's it. Now you know how to manage your data using DynamoDB and connect to a NestJS codebase. I hope you liked it, and I see you in the next time.